All right, so why don't we go ahead and get this thing started, get this party started, so to speak. I see a couple of show and tells. Let's start off with robot news, and I think the stretch robot from the ex-Googler and the Georgia Tech professor that looked pretty interesting. I got posted on the mailing list, and I also noticed that there's deploy spots, the Boston Robotics dog at Ford. I thought that was interesting. Any other robot news out there someone want to mention? John Carlini. All right, everybody's on the mailing list, right? You know where the mailing list is. On the HBRC homepage. Post the homepage there. And in there, you'll see our Google mailing list. So join the mailing list. That's where you all get all the robot news and the club news. Let's move the show along here. And how about club news? Let me mention that the HBRC challenge is done quarterly now. And so the next HBRC challenge is going to be in September. And we're a builders club. Everybody's building, right? And I'll be bugging you. Don't take it personal. I'm talking to myself most part. But I'll be bugging you all September long. And the September meeting is all show and tell. So you're responsible for a presentation in September, and partial credit for works in progress. So get your robot running for September. Also, I want to mention that I'm getting married on August the 15th. And I've put together this little robot called the Zoom bot. And I put my Zoom on. And so if you're interested in attending my wedding virtually, send me your email address and I'll send you a Zoom link. It's August the 15th, that's a Saturday. And the ceremony will start at 2 p.m. sharp. That's 11 a.m. Pacific time, but we'll start the feed at, help me out here, 1:30. That'll be 10:30 Pacific time. Any other club news out there? Oh, the SIG meeting last week was really good. The SIG Special Interest Group meets the penultimate Wednesdays. And we had 19 people and a couple of really good presentations and really good discussions. It actually, in a way, works out better than the regular meetings because the SIG is generally random access and people get in their own little groups. But here through Zoom, we kind of did a round robin sequentially, and it was kind of nice to, focus on each individual's projects and what they're doing and what they're working on and that sort of thing. So, that's the SIG, and of course, our special interest is Ross. So we've joined up with the SV Ross group also, and that meets the penultimate Wednesday before the real meeting. Hello, Ralph Campbell. How are you doing? Nice to see you.
Hi there.
All right. So any other more clues out there? Wayne, I think we're trying to get EJ Schurz with, what's the name of the company?
Cynthium.
Cynthium, yeah, we're trying to get Cynthium to talk.
See if we get him. Okay, I hope we do.
All right, well, I'll send him an email if that does any good. And your club news out there, Homebrew Robotics club news. All right, here comes, well, let's do the show and tell. Let's do the show and tell. Let me look at our chat.
Let me make one comment first. That is, if you're not talking, please mute. Most people I can see have already muted. If you're not talking and you're not muted, please mute right now. Thank you.
That's Dan Tuckler, our Zoominator there. Appreciate you Zoominating us. He's our controller. Let's see
Only if it
here.
goes well.
Let's see here. Let's see here.
People too, you know.
Ralph Hips, I believe you have a show and tell. Take it away, Ralph.
Okay, I got to
Typing,
unmute.
please mute yourself.
So whoever's
Right.
typing, you're a perfect example of why you need to mute if you're not talking. Thanks.
There you go. All right, I do have a show and tell, and this is, you guys hear me okay?
Yes.
Anyway, this is,
Ralph, you seem to have muted yourself. Ralph, we cannot hear you.
how about
There you
now?
go. That's better.
Okay, great. So this is Bane. He's a humanoid bot. Been working on it. It's a kit that I bought and a long time ago. Anyway, finally got the servos for it and starting to try to figure out how to make this thing do its thing. And I've made some basic progress. It's, you know, nothing too crazy, but, you know, it's a work in progress, right? So basically, I'm starting off with the idea of if he falls down, he needs to be able to get up. So that's step one, and that's what I'm going to show you real quick here. And see if I can do this all one-handed. Okay. And okay, there you go. He starts up, and he's going to stand up now for us, hopefully. We'll see how it goes. Well, maybe not. Oh, well.
Hey,
It's working fine. Let me give him one more try. What happened to him? I don't know. I'll have to watch him a little more closely. He might have gotten hung up on a cord or something. Oh, yeah, he did. He got hung up on that cable. Ah, right. Let's try this again.
Looks like me trying to do push-ups.
Huh? I got to finish putting the electronics on here, so I don't have all these cables hanging off them. That's my basic problem here so far. All right, let's try it again and see what happens. Okay. Make sure the cables don't get hung up. And if he stands up, okay. And there we go. That's it. That's pretty much my demo.
that's awesome, Ralph.
Thank you very much. Thank you very much. Yep, and that's pretty much it. Any questions, let me know.
What kit is that?
The frame is from SaneSmart. It's the 17 degree of freedom humanoid robot. You can get them on Amazon for, I think you can get them for 80 or 90 bucks these days. And then the servos are these sort of purple colored MG 996R servos. You can get 4 of those for 20 bucks on Amazon. And I like that. So all in all, right now, I'm going to do this for about 100, maybe about 200 bucks right now. And you just assemble it, and you're kind of on your own after that. So I'm been doing all the programming sort of the old-fashioned way, you know, one servo at a time, figuring it all out. But you know, having fun with it, something to do. And next, I'm going to teach it some dance moves. See how that goes.
Fantastic.
I didn't catch, did you say it's powered by an Arduino or something else? And what what programming environment?
Right now, I'm running it on an Arduino, which is actually a SparkFun Red board for the moment. And eventually that's going to go on his back. That's where all the electronics are hiding right now in this little plate here on the back of them. And there's some room there left for a small Arduino, either a Nano BLE33, that's what I'm thinking about right now, or maybe like a Pro Micro or something small. And I've got an Adafruit board to drive the 16 servos over I2C, and some power, and eventually an IMU, so you can tell if he's tipping or if he has fallen down, and then eventually some obstacle avoidance sensors, perhaps, that kind of thing. And that's where we're at now. Anyway, yeah, great, thanks.
Very nice. If you could post some parts and, you know, maybe a video or something on the mailing list when you get a chance, that'd be great.
Sure, happy to do it. You bet.
All right, Wayne, looks like you've got an update on the HR2.
Oh, okay, I hope folks can hear me. I'm going to try and show two screens here. So I'll try and do the first one here. Let's see how this works. Okay, are people seeing this? The robot with a purple top on it?
Yes, sir.
Yes.
Okay. So this is an update on my HR2 project. Okay. And it's based on a Pololu Romy base. And then I'm designing a new motherboard for it, in which I'm going to plug in all these sonars and something called a Nucleo 144 board, which is a product from ST Micro with one of their 144-pin ARM chips. And then it'll be a little hard to show this because everything's kind of cramped in there, but I have basically a Raspberry Pi plugged in underneath it. So you see that little green board down there, that's the Raspberry Pi. So that plugs in to the bottom of the board, and I'm going to give you a slightly better view here. I'm going to kill off the screen. I want to kill this, and give you a slightly better view. And yeah, see this one now. Okay, this one I took off the expansion plate, which is where the arm's going to be mounted. The arm will, you see the slot at the beginning? The arm's going to reach through that slight slot so it can get down to the ground level. This white board here is the Nucleo. And I have, for visualization purposes, I've cut holes in it. It's actually a solid board. It's all electronics and stuff, but I wanted people to be able to see through here. Okay. The next thing you'll notice is I want to work with the Raspberry Pi 4, and the Raspberry Pi 4 runs hot. So I put some holes in here for the heat sinks. So there's 2 heat sinks here for processor and memory. If you look a little bit over there towards that bottom back corner, there's 2 more heat sinks for the USB and Ethernet. So hopefully I can get rid of all the heat so it doesn't overheat. And then in order to pull this off, I had to design my own encoder boards. It's the ones that come with that you can buy from Pololu, or I couldn't get everything to fit with them. So I figured, hey, it's only about 5 or a couple of Hall effect sensors and a few resistors. So I said, why don't I just do my own board and be done with it? And actually, I've got a total of 5 sonars on top. Currently, I have, let me go to a top view here. Currently, I have 16 LEDs around here. I don't know if I'm going to wind up with a total of 16 LEDs, but I figured I'd put as many on as I could. And if that ran out of pins, I'd drop them. And then let's see, let me move this over. The other key thing on all this is that brick in the center on top of the motor, that's the Ethernet connector. I needed to leave enough room to get an Ethernet cable in there so I can plug it into a Raspberry Pi. So this thing will be able to talk to the microcontroller over Ethernet if you want, Ethernet or serial. And this is a full up hat. You can see that black thing in there. That's the MIPI cable for the Raspberry Pi camera. And then it's a little forward here. And there's another slot there that looks showing up kind of black. And that's for the LCD panel for the Raspberry Pi. Okay. And that's pretty much it. I'm wrapping up the mechanical design. I had some problems fitting everything in, and I got really distracted with some things, so it's taking longer than I would like. But I'm hoping to start laying out printed circuit boards maybe either this weekend or the next weekend. So I should start making some progress again. So anyhow, that's where I'm at. I just thought, it's been about 3 months. I should give people, let's see how things are going. I'm open for any questions if anybody wants to ask questions.
Hey, Wayne, what kind of battery and what kind of payload can it have?
Okay, battery is going to be a USB power pack that you use for recharging cell phones. And the reason for that is because they're really available on eBay and the like. And they're easy to swap in and out. So I'll just be taking that to a USB connector of some sort to get power out. The payload's not going to be great on this. I probably have it pretty loaded up already. So I'm not expecting the payload of much more than I'll be surprised if it can carry much more than a pound on this thing. Okay. This is not a work robot. This is an educational robot. It's for teaching people how to build robots. It's not necessarily for actually getting something done. You're going to need a bigger robot for that.
Think you get?
Another question?
You think you get 30 minutes of continuous use out of a battery? Because the Raspberry Pi gonna suck a lot of power.
I think I have enough room to put a pretty beefy battery pack on there, but your concern is legitimate, and it'll be as long as possible. But the key thing is, if you run out of power, you just get another USB power pack and plug it in and reboot and go. So.
Yeah, the bigger ones are pretty capable. I run a Raspberry Pi 3 based robot off one of the larger ones. I'm not sure how many milliamp hour it is, but I get over 24 hours if I'm not using the motors too much.
Yeah, I really don't have any good feel for what the power consumption of this is going to be. I tend to design my electronics so that all the high power things are off. So, I'm pretty sure if it's just sitting there, it's just going to be running the Raspberry Pi, and that has power management features in it. So if you're not running full bore, it probably won't take too much power. But if you got everything on, yeah, it'll probably drain the battery. That's just like.
So this kind of looks like grandson of Loki.
It is, in fact, grandson of Loki. Most people don't know what Loki is. Loki was another robot platform I designed. We put on a Kickstarter. I don't think anybody signed up to buy any. So
Progress, not perfection.
There were two
Yeah.
whole pledges for Loki, so
Yeah.
it wasn't a great idea.
one of the
Yeah.
Okay, I think that's about it. So let's go on to the next person. Okay. I'm going to stop
All
sharing.
right, thank you very much.
Welcome.
Let's see, Carl from Canada. Looks like you're up next.
Okay.
And Jeff.
Yeah, okay. So you can all hear me, can you?
Yes.
Okay. All right. So this is, hold on, let me turn the camera around. Is it going to work? Okay. Let's try that. Right. So this is a demo I was originally planning to do a couple of months back, but I got stuck into a little bit of a family emergency. So I think you've all met Kate before. And she's going to play chess. But a few of the more observant members might notice she hasn't actually got an arm, but that wouldn't stop her. Okay, Google, let's play chess.
Okay, please set the board up.
So she's going to, so this is, so Kate did a ROS demo at the SIG, but this is not ROS based. This is the other image that it needs to. I have a switch to switch the images. It's not actually using the rotating LiDAR on the top. This is just doing wall following for a set distance. And you'll see how it plays chess in a moment. I'm not shortchanging you. There's a game of chess coming here eventually. But she's got to get to the board first. So she's just following the wall using the TF Mini LiDAR, which is just a single point one-dimensional LiDAR, which is on the pan tilt. She goes a set distance. That's a gyro-controlled turn of 90 degrees. Okay, then a gyro-controlled turn of 45 degrees. And then she'll come along here and she should stop at about the rug interface, which puts her in the perfect place to play chess. So, and she plays like this. So when she's looking at me, which she is now, that means it's my move. So, okay, Google, echo 2 to echo 4.
Okay.
When she's looking down, that's her move and she's thinking.
Golf 8 to Foxtrot 6.
8 to Foxtrot 6. Okay, Google, Delta 1 to Foxtrot 3.
Okay. Bravo 8 to Charlie 6.
Okay, Google, Delta 2 to Delta 3.
Okay.
Don't worry, I won't bore you with the whole game. She always wins
Delta
anyway.
7 to Delta 5.
Delta 7 to Delta 5. I won't carry the game on because I say she always wins. This is actually the cleverest bit now. Okay, Google, I resign. And then we'll send her back to the charger. Now this is the bit that's cleverest because all of the motion is all dead reckoning. So it's not using any of the localization and stuff that was shown on the SLAM demo and so on as I did today. So it's all dead reckoning. I'm going to send her back now where she started from, and hopefully if we get this right, she'll actually end up pretty close to where she started. Okay, Google, go to the charger. So it's a measured distance, then a 300 and whatever it is, 320 degree turn. Sorry, 107, whatever it is. 100 and, then she uses the ultrasonics to avoid collision detection of the wall. Then she follows the wall with the LiDAR. And then hopefully she'll end up and get back where she started from. So it's just a measured distance of wall following to get back to the charger.
Say, Carl, I noticed you've got Nito boundary marker across there. Are you using that?
Not for that. No, that's so that the vacuum cleaner doesn't beat her up.
Got it.
And
Sounds like a charger.
and she got back to where she started from. Okay, Google, disco time. And with that, I'll hand over to the next demo.
That's awesome, Carl. I have to tell you, you triggered my Google Mini a couple times during that demo.
Yeah, I'm not sure if you heard. I've got one in the kitchen that was going off as well, so there's no problem. I need to get a custom wake word for it, but
Did you write the algorithm for the chess, or is that something you picked up somewhere?
that's something I picked up. That's using very standard GNU chess, which is it's even built into some versions of some distributions of Linux. So it's very, very standard. Plays a very, very good game though, unfortunately, and there's no way of cobbling it to play worse. So it pretty much always wins.
Fascinating. All righty. Thank you very much. Carl from Canada. It's Pickens, right?
Pick in, but close enough.
Pickin, gotcha. Carl Pickin from Canada. Thank you very much. I have a few demos. Let me get them here. So I'm writing a book, okay, and I'm trying to put together some simple iterations on a tabletop robot. This is I'm picking up these micro servos and wheels for $5.50 a unit. That's $10.50 for the pair. I've got a Arduino Nano here and snap action switches with the bumper. Let me turn my Zoom bot around. Test 1, 2. Let's see. How can I, can you focus the screen on me, Dan?
I don't know. Individual people can pin you or put you in presentation mode. Hang on.
All right. Well, then I'm just going to switch this guy on and have him run. Let's see. Can you see him on the screen? Okay. Oh, there's my screen. Yeah, you see him right there.
Okay, I pinned him, but people have to put their screen into speaker view.
Yeah, this is another one. And everybody recognizes this chassis from Banggood. It comes with DC gear motors. And I found these really fantastic two-channel controller that you can use the RC pulse width modulation. One millisecond it goes forward, 2 milliseconds it goes reverse, 1.5 it stops. And this is the same kind of thing. I've got the wheels and the micro, the Arduino Nano, and just some simple bump action switches. It's got a caster wheel too. Send that guy on his way. And I'll probably have to drop some coin on the mailing list for this one. I picked up 50 of these chassis from China and from VTech. And I've also got the same two-channel controller here. If you're interested, I'll sell the chassis with the controller for 12 bucks. Basically, Robot Shop, they sell the chassis without the controller. It's kind of a ripoff. They've taken the controller out of the microservice, so it's just a DC geared motor. But again, I found these little two-channel controllers very useful because, again, you can treat the small DC motor as if it was a servo. And so I'm going to switch this guy on and send him on his way. Now, finally, everybody knows my SV Ross Intro to Ross demo using the bot back with the Raspberry Pi inside the dirt bin. And I've written code, I call it Floorbot. And my Nito bot vac has been circling around the house here probably about 4 or 5 times. Now, when I did the demo at the SIG, it actually went around the house 15, 16 times before running out of energy, which is pretty good. So you can see I've mapped the house, and the robot's been going from the computer room through the kitchen, through the hallway to the TV room, and around and around and around. I'll just pick him up on his way virtually. Can you see him there? There he is. So technically, I'm demonstrating 5 robots at once now. So this is the SV Ross, Intro to Ross GitHub. And I think folks are familiar with it, but I'll post it again on the mailing list. I've done some things, including decrease the boundary boundary on the inflation boundary on the walls, and it really makes quite a difference in the navigation. We still have the robot. There he goes. No hands. This is all autonomous, except for the Zoom bot. Anyways, you get the idea. There's my cat, Sweetie. Say hello, Sweetie. Anyway, let me go pick up the nano turtles now. They're still roaming around. And that's the Nito turtle bot driving around. And I've got the computer Velcroed to a Zagros base here with a TurtleBot superstructure. And I'm calling it the Zoom bot that I'll use at my wedding. So it's August the 15th. Guys, send me your email. I'll send you a link. And you can zoom in on my wedding. So who else has a demo out there? Speak now, forever hold your peace. Okay, let's move into a new segment of the program. Hang on a second, let me go get these nano turtles. This is the one with the Feebig base. And this is one with the standard Banggood base. And this guy here is probably the most homebrewed of all, with 4-inch acrylics, kind of like tab plastics. And I use Instamorph, like Shape Lock thermal polymer here for the standoffs, and patented popsicle stick technology and snap action switch extenders with the cardboard. So are there any other demos out there before we move on to the next segment? Let me double check my the chat here. All right. So the next, we're going to do something a little bit new here. It's called What People Need Help With. Is there anything out there that folks are working on that they could use some help or advice or suggestions on?
I have a request.
Go ahead, Dr. Ed.
So I have recently discovered Raspberry Pi 2. I know this is kind of an ancient topic, but I'm finding that it has a lot of potential, not necessarily in applied to robotics, but in terms of distributed applications where more than one of these would cooperate together. So I was wondering if people in the Robot Club who happen to have some Raspberry Pi 2s just sitting on the shelf that could use a good home, and you wouldn't mind, instead of recycling them, to pass them on to me, I'd appreciate it. If it's the same situation with the Raspberry Pi 3, I'm not prejudiced. But if you could also donate the power supply with it, that's also great. Thank you.
Dr. Ed, why don't you put your email address in the chat there, so if somebody's got
Sure will.
twos that they're not using, they can get in touch with you.
Sure will.
So I'm gonna start working on the bumper package on the Nito BotVac Intro to ROS again. So I'll probably connect with you, Mike Wimble, because I know you have experience with that, but I'll post to the mailing list and try to get something going on that. Currently with the Intro to ROS BotVac package, it runs strictly off the LiDAR. And we've got the bumper package going, but when it bumps, it hears a bump, and apparently then you need to communicate with MoveBase somehow to tell it what to do once you encounter a bump. But that's where I am with that. Does anybody else need help with anything, questions, something that you're working on that, you know, somebody in the group or club might have some ideas?
So I had a question. Does anybody have experience with monocular visual SLAM, or basically just basic navigation pipeline? Like I want to use a camera, Raspberry camera or something, and say it detects the table edges, either using fiducials or just using camera to determine the edges, and just do a traveling salesperson, or just move around the table within the boundary.
I've started playing with my own version of the JetBot. Might be worth checking that out. Doesn't use Raspberry Pi, it uses the NVIDIA Jetson Nano. But there's a whole community around that, which is doing exactly that. It's basically just a Jetson Nano and a Raspberry Pi camera.
Does it use ROS or just raw?
You can use ROS with it. It has a ROS extension, but it's basically like a reference architecture for putting together a vision-based AI robot. It's very, very simple.
Yeah, I mean, I was looking for just basic, not ROS. I mean, I could extend it to ROS.
So the basic comes with, I mean, their image comes with tutorials on basically doing everything. I haven't got very far with it myself just because of time. I've had some problems with the Wi-Fi driver on it, but if I just flip my camera around, I can show you what the actual build looks like. Just bear with me a moment. I mean, it's very, very simple. Mine's just based on a cookie tin. That's it. It's got a ROS sticker on the side, but I say the ROS is definitely not essential. It's not running ROS yet. It's just a camera. That camera's on a pan tilt, but the reference architecture for it doesn't actually need the pan tilt. It's just a fixed camera.
Is that a Jetson Nano?
Yes. Yeah, Jetson Nano on the top of it. Yeah. Yeah.
So is Jetson Nano a dependency?
Yes,
what operating system does it run?
It is a dependency. The reason it's a dependency is that all of the vision is based on neural nets, which I think it's called TensorRT, which takes use of the GPU on the Jetson Nano, which is fundamentally what the Jetson Nano was designed for. So the Jetson Nano was kind of designed as a very, kind of, if you like, a Raspberry Pi competitor that can do machine vision.
Got it. Yeah.
Yeah, certainly we could take a look at that.
I'll take a look at it.
What I was trying to do is take all the capabilities that are on Kate and all the capabilities that are in the JetBot with the vision, and also throw on a depth camera of some sort, and build a bigger robot. Possibly the bigger one will have both the Jetson Nano and a Raspberry Pi, so I can do things like the Google Assistance and voice control from the Raspberry Pi, but leave the Jetson Nano just for doing the vision and that kind of thing. So that's kind of where it's heading. So they're two different separate robots at the moment, but there'll be a bigger one that encompasses all of it.
Yeah, and you mentioned that you were also looking at the Raspberry Pi and possibly doing fiducials with co-founder of Robotics. We have some open source packages that for fiducial stuff in ROS. So if you were going to use ROS, it would be a good way to do it. You mentioned you may not want to use ROS for your project, but
not to begin with. I just I wanted to get the basics. I was thinking that basic image processing and edge detection should get me where the edges are, and then I can just navigate the robot to stay within the boundaries to start with, and then start looking at how do we scale this up with ROS or something like that. So definitely we'll take a look at that.
okay.
Hello. Yeah. So for monocular SLAM, you can look at a package called Orb SLAM. SLAM is used a lot for monocular, like SLAM, just from images.
Yeah,
Okay.
and Stanford developed something called GoNet, Go-Net, which uses fisheye, 360-degree fisheye, to do prediction of what's going to be in the next frame. So it's not technically SLAM, but it is vision-based navigation. And then if something enters a frame that's unexpected, that's recognized as a hazard and stops the robot from running into it. What's really cool about it is it's in some ways it's better than LiDAR, because it'll detect things like, oh, there's a big pit in front of me, or hey, there's a glass window. You can see a glass window where the LiDAR just goes right through it and doesn't see it. It's GoNet.
GoNet, okay.
Yeah, it'd be technical papers on that. It, wouldn't be popular, and you'd have to develop your own algorithms.
Wang, can you post a link to the item that you mentioned so we can read further about it?
Okay, I'll put on chat.
Yeah, thanks.
All right, does anybody else need help with something? Speak now. All right, well, let's
I need help with something.
Hey, it's Steven, right?
No, it's Jim.
It's Jim with RoboBricks.
Yeah, what I need help with, I have a 3D printer with a dual extruder, and I want to be able to make something with two different materials, one of which would conduct electricity. Does anybody know of a filament that you can use on a 3D printer so that you can print in there some electrically conductive paths?
So you're trying to print circuit boards?
Something like that, only in 3D.
Well, I'm trying to remember the name. There's a place I've bought a lot of filament from. They have a lot of exotic filament. You know what?
Protopasta?
I'll put it, what's that?
Protopasta?
Protopasta is a brand name of filament. And yeah, you might want to look at that because they might have some that's conductive. Any of the filaments that I've seen that are conductive do have a really high bulk resistivity though. So you aren't so much printing conductors as you are printing resistors.
I see. Yeah, it has problems heating up. Some of the contacts will degrade real quick. I've seen some videos on YouTube that are trying to print it, and it really hasn't been very successful. Well, I'm thinking in terms of what could I, in some imaginative way, what could I do in terms of the robots that I design and build if I had the capability to use the dual extruder 3D printer that I own. And it wouldn't matter if it's ABS, nylon, PLA, but those all are electrical insulators. If I could use the other extruder, and even if the traces have to be fairly thick to get the resistance down, to actually print in there some electrical pathways. I'm thinking in terms of sensors that I could conceivably build. it might actually be better if the conductive pathways have a reasonable amount of resistance for certain sensor applications.
Very interesting.
Oh, did I
I'm
show
gonna-
you this thing? I don't remember. I haven't been to your general meeting before. There's a book titled Godel Etcher Bach, and it shows some computer graphics on the front in which a carved piece of wood illuminated by 3 beams of light casts 3 different patterns. So I tried a hand on making this thing. So here's the letter B, and here's the letter E, and here's the letter G. So when you see something in artwork and you kind of guess that it's computer graphics, you don't know if it's even physically possible to build something like that, because it's so easy to cheat with computer graphics. You only have to show the external surface. It doesn't have to be real. So it turns out it can be done because I've done it.
Say, Jim, are you on our mailing list?
I believe I am. I was at last week's online meeting, and then after that I signed up to your group.
Great. Yeah, post your 3D printing question on the mailing list, and you're bound to get some interesting responses.
Okay, thank you.
Anybody else need help? All right, let's move into the main presentation here. The presentation will be given by our own longtime club member, Brian Higgins. He will give a talk on sensing and navigation efforts for the visually impaired. 2018 candidate for the Holman Prize. Brian has worked on several things for people who are blind and visually impaired, including an autonomous guide robot, a running cane, a bicycle for the visually impaired, and the smart white cane. Brian's now exploring development of Loomo, the robotic Segway for use in blind and visually impaired navigation. Brian Higgins, go ahead, take it away.
Thank you. I have a PowerPoint. Before I go there, one of the items that would be at the end of the presentation, the latest iteration of the smart cane. I've been working on this week, so I didn't get it into the presentation. Plus, I'll do a quick little live, but I kind of got into folding plexiglass, so I'm not sure how much you can see, but I folded this frame to set the LiDAR in, and so it's kind of cool. If you don't have a 3D printer and you got a heating element, you can fold plexiglass into quite an array to hold different sensors. So this, I think my smart cane, once I get a 3D printer and can print a housing to handle the ultrasonic that goes along with that, it will be a much different story. But this week I just introduced myself, or went in depth on folding plexiglass. And just a real quick demo of what a blind person would hear. I can actually navigate in a dark space following these different sounds. And so this is something I'm wearing around my neck lanyard. And I've actually had a ultrasonic version for quite a few years that a gentleman in Australia makes, and this makes similar sounds that you can navigate by, and you can find a clear path through an environment. So those are a couple things I didn't get in the presentation. Now the presentation, if Dan would like to launch that, this is a PowerPoint I did.
Yeah, I'm just going to remind everybody, if you don't mind, please go on mute so we can hear Brian.
So I'm going to explain a little bit about how I got here. I'm sort of a homebrewed amateur that's tried to use things that are somewhat available. And you can see kind of my history here. I'm a blind vet with retinitis pigmentosa, which is tunnel vision and night blindness. And this, did I say that this was created, this PowerPoint originally was created for the Ford Autonomous Lab here in Palo Alto. But I spiced it up for the homebrew robotics people so you can see what I've gone through with very little robotic experience. And I've been in the club for a few years, 15 according to this. I worked at a VA blind center for 20, photographer for 50, and I started following autonomous vehicles 30 years ago. A friend gave me a news clipping, which I'll show you in a minute. And this is how I've got on this road, because for the blind and visually impaired, the most traumatic disability portion is transportation. Everyone here probably can just go out, jump in the car, and go anywhere they want. It's a real work to get a ride to go somewhere. So next slide. So my first robot, the one on the left, not the PR2. Actually, the PR2 is one of the first professional robots at Willow Garage that I was exposed to and got experience with. And actually, this little robot is probably my last robot when I decided sensors are probably the way to go for me and to keep exploring sensors. So now if we go to the next slide. Now, I'll try to go through this quickly. This was for Ford again, but I'll just touch on a couple areas because I think there's a real market for creating sensors for the blind, and you can see the amount of people in the world. There's millions. So I think 1.3 billion people with some vision impairment, but there's 188 million with mild vision loss, and then 217. So there is quite a market, and there is a big difference between low vision and blind. Most people believe someone who's blind is total, but only 10% of everyone who's legally blind and low vision have probably some perception, light perception. So if we go to the next slide, this is just one of my pictures of the retina. Because initially, when I became diagnosed with blind, I said, should I invent something, invent the retina, or invent transportation? So the next slide. So vision is all about visual perception. And you'll see at the bottom, retina. You'll see why I didn't go with inventing a new retina. And there's 126 million rods and cones. So you take a quarter, silver quarter, and try to put 126 million dots on that. That's your retina. All right, next slide. So the rods, you can see we have a lot of different types of vision. And so you can see low light levels and peripheral vision is what I've lost. Next slide. And then 6 million cones, which is less, but this gives you color vision, high resolution, etc. One important thing to connect what we do, or what you guys do, the retina, if you equated it to a camera, that's 576 megapixels. So I think the latest iPhone is 12 megapixels. So you can see a big difference in the retina and the challenge of creating another retina. It's, I don't see that happening for a while. So next slide. And this whole process is another process that maybe robotic people don't go through. But so I've been studying this for a while. This is my vision. The left side photo, there's 3 photos. The one on the left shows kind of normal vision of a fence going off into the distance. The middle one was when I had cataracts. This is my tunnel that I see and get around with. And I recently had cataracts removed and I got brand new lenses in both my eyes. And so the image on the right is kind of what I see now. So next slide. We're kind of jumping ahead, or I've kind of mixed this up probably, but still explaining my vision. I showed you the peripheral of the pinhole. Now, when you go in a store, someone with retinitis pigmentosa, that's the bottom ones, what they see. And then normally you'd see that fireplace with a saddle on top. I've recently discovered the iPhone 11 Pro Max. It actually has become a guide phone. I still go in the store, I still see that black image inside anywhere. But with this guide phone, if I look through it, I can see what you guys see on top. So it actually is providing, it can see better than I can, even though it's only 12 megapixels and not 576 megapixels. All right, next slide. All right, like I said, the biggest issue for the blind vision impaired is transportation. And not many people on a national level are doing much. I mean, there's all kinds of transportation, but so next. Photography is my life passion. I gave it up because of vision loss. But Kodak says photography is the art of seeing. So I think I have a lot of insight in what I'm doing because I understand how people see and optics and so forth. So next. So autonomous travel. A friend of mine gave me a pamphlet, a newspaper pamphlet or magazine article about autonomous travel. This was Carnegie Mellon in Pittsburgh, mid 80s, I think. Alvin, and it filled the whole van with computer stuff, the whole van just to drive 10 miles an hour. So I decided to follow this, that autonomous travel. I believe that, and I've tried to talk to Google and Waymo and all those, but the car is to the road as the blind person is to the sidewalk. So that's one of my premises. So next. So this is the article that a friend gave me, Driving Solo. This is about Carnegie Mellon, Pittsburgh, way back. So I've been doing this for a few years. Next slide. More of the article. Next. Alvin, you can see his name. This is one of the opportunities I had at American Council of Blind National Convention, where Sebastian Thrun was asked to speak about autonomous travel, I guess 2006, according to that. But I was up there speaking with him, and we each took turn, and I was explaining what little I've done back then and how I'm hoping that the blind will be able to drive someday. I'll be able to drive again. Okay, next. And I've worked with a few universities. Ed really got me going. You'll see a slide about him in a minute. At Stanford, we tried, I built a running cane and I wanted them to improve on it, but we actually bailed on that. And you can see One More Mile. If you look Stanford Accessibility Group, One More Mile, you'll see the whole article. But I bailed on it because I started to realize that Stanford would have anything these students do, Stanford would have the license to that. So next. So again, I credit Ed, Dr. Ed, with a lot. CMU, where we used to meet. Nito helped. Camp was a great inspiration. He sold me one of his kits that he had way back in the day. And that's one of the first things I built. Ed also has this YouTube video. And I don't want to click on it, but I think I did send this out to the group a while ago, and anyone that wants to see it, see Ed in action. He's portraying a blind or visually impaired person. And one of his graduate students wrote the software and took him with a Nito vacuum cleaner and my aluminum tube harness on the Nito vacuum cleaner from one room to the next. So if there's any interest in seeing that again, I can repost that. Next. All right, so I'm more of a MacGyver. You give me a toothpick and a paper clip and some glue, or my favorite is the Sugru, which is fantastic. You'll see it on all of my sensors that I've got going. And because Velcro, that's 25 mile an hour Velcro. The first Segway I had several sensors Velcroed with this, I call it 25 mile an hour Velcro. Now at the bottom right, you'll see I took a Nito and I did all kinds of things with it. I had someone build a frame. We put into 8-inch wheels. I tried different harnesses, experimented with kickstands. That's what those are in the foreground. In the smaller box, I can't remember what I did, but I dug all of these out the other day and took pictures. And you can see a Nito that slides into that frame that has the 8-inch wheels on it. So this is just taking things that are available and trying to, because I keep trying to learn code and I get sidetracked all the time and know very little bit about code. So next. All right, so this is after what you just saw. This is what I put together initially. I went to the gray box. I went to, where'd I go? Prize, and got the gray box and went online, spent quite a bit of time on wheels, 8-inch wheels, and I chopped up a Nito and put part of it on there with the LiDAR on there. And then I think I think I'll show you what inside I hooked to that. And actually at my office, I can plug the USB into a computer and it will show the LiDAR spinning. But I primarily use 3 mini guides, which is ultrasonic sensor, which is fantastic. It's well, when I first started using it, it was 4 meters, 2 meters, 1 meter, and a half meter. And you can change it and set it. So I had 3 of these at 3 different zones. And so with a collapsible harness, and you can see the kickstand and back, which if you're on a bus, you could always stick your foot on that so it doesn't roll away from you. So this was my first guide robot for the blind. And sensors, LiDAR, I never really got hooked up or programmed. Oh, Inspect or MDPI, that's something that I came across that they say LiDAR, what you really need, the 4 sensors you need to have a totally autonomous robot like this would be LiDAR, radar, depth camera, and ultrasonic. So that's something that once I get my cane done, I may go back to this. Next slide. All right, so this is the guide robot. Oh yeah, there's the, I don't know if you can read that, I can't, but that's the little programming board that's inside in the gray box, and that's the LiDAR that's on top, and that's the demo piece that I hooked up because I never got any further than plug it into a laptop and watch it spin. And then in the middle, you'll see on my running cane, the ultrasonic sensor, GDP in Australia. The guy is a rocket scientist that developed this for the blind. And I have a speaker hooked up to it, so when I run, I get an audible signal. And so it's just one sensor. I think there'll be a better shot of the running cane in a minute. But if you want to look that up, that's an excellent sensor. Uses a 3-volt battery, which lasts a year or so. All right, next slide. Yeah, so that's my running cane. Instead of one white cane, it's two long white canes hooked together. And then I have the mini guide on it with a speaker. I tried Bluetooth, but Bluetooth I found unreliable. And I'd love to find the speaker on the left. That's an amazing speaker. I don't know where I got it, and I haven't been able to find another speaker like it. So if this dies, I'm in trouble. So, and then on the right, you'll see two different versions. I tried to taper the handles and experiment. So this is my experimenting. Next slide. All right. Oh, this is when I first learned of the LiDAR light by Garmin. A V3 is what I used. And I did hook this up to an Arduino Uno. You can see the breadboard with a capacitor. This was my first, so I dated this. I think this was like 2 years ago when I first used this, and I could see it printed out on the computer screen distances as you move the sensor around. So this is my first experience with this, and I found this to be great. And this is what I'm trying to perfect currently. So the next slide. All right, so bike sensor, I tried the mini guide on the bike sensor. I tried the mini guide with the speaker on my hand. And then you'll see the LiDAR with a cell phone power pack hooked to it. And then there's a USB on off switch. Some reason I this one for some reason. And then way over on the right-hand side, you'll see a cell phone hooked on my bike. So this is my setup for the bike. I'm also connected. I got approved to work with San Luis Obispo. The QL Plus project is a project where for disabled vets, this gentleman who used to be in the CIA put up money for colleges to work with disabled veterans. So they're going to try to elaborate on my bike and make that accessible to the visually impaired. The next. So as in the white cane, it's a symbol. And so one of the things I did for my bike, you could see on the very front, I have a sign that says blind. And a lot of reaction from drivers, a lot of caution on their part, which helps. And then on my backpack on the back, it says blind biker. And so this is my, in lieu of a white cane as a symbol that I'm blind, visually impaired. So next slide. All right. Okay, so this is when I decided the stigma of robots, and I've tried to get grants, and I've tried to work with NIH, NEI, all these national organizations that have money, no go. You know, robot was too scary, or before the pandemic, robots were too scary for people outside of the robot community. So I figured I gotta do something that people will not be so scared about. You know, no one wants to put a blind person in a car behind the steering wheel. So I said, the smart white cane for the blind is where I'm going. And my push is that we've been using a white stick for years. It's time to have a smart cane. So that's my mantra. So the next slide. All right, so here's a picture of the close-up of the sensors on my smart cane. It has an iPhone, has the Garmin LiDAR Lite V3, an Arduino controller board, the Pro Micro. It's buried under the Sugru. Mini guide, the ultrasonic sensor, and a headlamp. That helps me with my condition. There's 100 different blindness conditions. So a custom cane is probably something that'll have to be done. But when I get indoors, This bright light helps a lot. And I'm really just trying to expose people to additional sensory information is what I'm doing. This one LiDAR sensor along with the ultrasonic is not going to make it autonomous, but it's going to start to prepare people for driving the autonomous vehicles once they get on the road and once we are being able to drive them. They're going to let sighted people drive first, and the smartphone, there's a couple really cool apps, a talking GPS that provides a GPS location and a talking mode for the blind. And then Ira is something fairly new. You can actually, just by touching on an app, and the iPhone is totally accessible, someone totally blind. So they can go to this Ira app and contact someone in a call center who can see through your camera, and you can provide sighted guide. So this is why the smartphone is part of my smart cane for the blind. This is kind of a rundown of what the smart cane is about. The next slide. So there's more shots of this, different angles showing the mini guide, the LiDAR, and the piezo speaker. It's so loud here, I put a foam gray dot on top of it. And then there's the lily pad vibrator. When you get real close, it's like a last minute warning. It starts to vibrate. So there's different levels of sensing here with PWM and GitHub code that I downloaded for the Pro Micro. All right, next slide. And I have a light on about everything going. My baseball caps, IntelliSight is my company. And so I have lights on every hat I've got going, on the cane, of course. And there's a close-up of the current sensor, the battery. I've been searching for the smallest battery I can because I'm involved with a program now at the VA. The VA has finally gone AI. There was a fantastic webinar a couple months ago about robotics for surgery and healthcare. Healthcare is a big, big market for robotics. Silicon Valley Robotics put that on, and Andrea, I'm not sure of any, I think a few people may know her, but she put on this surgeons and healthcare and robotics. I participated in that. And so this is the sensor, and you have to, one of the things with a Pro Micro, you have to solidify your USB micro cord right to the board because it'll snap off in no time. You can't use a USB cord for very long. It'll break it off. I broke it off several. So next slide. All right. This is the future. Intel RealSense. I purchased an Intel RealSense D435i because I don't know anything about it. RP LiDAR S1, a 360-degree time-of-flight laser, is something that just came out. And this is how I functioned. I tried to, through the last 30 years, I've tried to stay in touch with what's going on, watch what's coming out for sensors, and do what I can with my limited knowledge. Now the Loomo is next. So next slide. This is pretty exciting. And I think my smart cane for the blind will be part of this. An average cane is about 5 feet long. It's great for social distancing in these times of COVID. But this cane that you're seeing at 10 miles an hour on a Segway, you need more than a 5-foot cane. So I developed this 5-foot cane, and hopefully it'll put all the sensors on this. And this is it's a Segway, and I've had two in the past, the old style, but this is brand new. Actually, this just came from China. Well, I think it was in a warehouse, but at the beginning of this COVID, I bought this and had it delivered, and there was Chinese all over this, and I didn't dare open it for a while. But I was reassured it was in a U.S. warehouse for a couple of months and didn't come straight from China. So I unpackaged this guy and got used to riding a Segway again, and it's robotic. It's two different types of programming. And let me get into I didn't get on my laptop here, I got a larger list of the sensors. So this is my latest thing that's quite exciting. I think can be an excellent companion for the visually impaired. This has a HD camera, 1080p by 30 hertz streaming that can do video. You can give it voice commands. You could say, "Hey Loomo," and then when he comes around, he says, I give the command to follow me, and he'll follow me through stores using the Intel RealSense ZR300 camera, the depth sensor. He can avoid things when he's following me. That doesn't help the blind any, other than the companion. So it has an ultrasonic sensor, infrared distance sensor, touch sensors, encoders, 6 IMUs, a processor, Intel Atom Z8750 4 core, 256 gigahertz, x86 64-bit, operating system, Android 5.1, which I know nothing about, but if I was really going to get serious on programming this, now I programmed it with blocks. Whoop, I went off that page. I programmed this using what kids use in school, dragging blocks around, and you can program this to go out 10 feet, turn around, come back. I also, the VA, if you go to the VA hospital, we have what's called screeners. And anyone entering a VA campus, they'll stop you and ask you, do you have a cough, fever, shortness of breath? Have you been exposed to COVID recently? So I actually trained this robot to say that. There's, what do they call that? I'm thinking of a word. But it can emulate you with your picture and 64 gig storage and 4 gig of memory. So next slide. We're almost done. Whoops, okay. This is the RP LiDAR. This is kind of the next. I don't really believe I have a protocol that I've created. I call it the 10 degree of surface navigation clear path detection. 360 degrees time of flight laser would be great, but unlike an autonomous vehicle, I don't think you really need. I'm only really concerned with about 10 degrees in front of me. So whatever compass heading I'm on, that's the 10, or even less than 10 degrees. That's what I'm concerned with. And things will come in my path. But that's the protocol that I've developed. And then I think the last slide is a teaser that I did for Ford. I tried to get Ford, I think it was February, I spoke to the Ford Autonomous Lab. And I have a forever battery. So my cane that I use, I've had that phone battery. It's a power bank. It's the lowest 1900 amps, I think, 19,000 amps. But it's the smallest battery I could get on the bike and on my white cane that I use. And I've been using it for 2 years without ever charging it. So that's my teaser to people with battery issues. And that's the conclusion of my PowerPoint. I can entertain any questions. So I thank you for having me. It was a pleasure. I've been following, this group for a lot of years, and a lot of people have helped me. I thought I had a list of names of people, or maybe in what's on the web, but I think Ed, of course, Camp, Nito helped me out. Let's see, Dave Curtis, Mark, recently Chris, Andy, and the list goes on. So that's my presentation. Hopefully there was some inspiration or some, so that's the journey I'm on.
Great presentation.
Brian, what is it about that mini guide that's so special?
Well, it's commercially available. It's ultrasonic. I mean, if I could build and program an ultrasonic sensor, I probably could, but it's, and actually I started working with a gentleman in Australia, and it went out 4 meters, and I bugged him for a couple of years, and I said, it's got to be further out. And so it's now, the current version goes out 8 meters, but you can change the settings. So if you're in a busy shopping mall and you need to change the settings to a ½ meter or 1 meter, so it doesn't go off all the time. But if you're out on the sidewalk, you may want 4 meters or 8 meters. So it has the flexibility of changing its range, and ultrasonic sensors are quite common. And if I had the ingenuity, I could probably build one to go along with my LiDAR, but this was just, I tried to go with things that are available, and that's what I went with. Actually, I started out 20 years ago as a wedding photographer. I wasn't going to start using a white cane because bride and grooms would get very nervous to have a blind photographer. So there was this ultrasonic sensor, and I, again, blanking on the name, but had two settings, 3 feet and 9 feet. And I just used that, held it in my hand down by my leg, and I could flick it back and forth to make sure I didn't bump into anything.
That was the Mowat sensor.
Yes, thank you. Mowat? Yeah, thank you. I still have mine. I've dropped it so many times I had to resolder the vibrator in it, but yes, thanks.
Any other questions?
Brian, you seem to use LiDAR a lot. They don't see glass and they don't operate outdoors very reliably. What's your opinion about that?
I recently talked to, I've been talking to Spark Fund, who is a distributor of Garmin, and actually they do work. I know there is issues with glass. That's why my Smart Cane has the ultrasonic sensor in combination with the LiDAR. So there's going to be two. The LiDAR is going to be a much wider angle, of course. So you'll have both those sensors to rely on when one doesn't provide what you need. And again, this is just additional sensory information. The white cane keeps the blind person in contact with the sidewalk and the ground and the surface and drop-offs and all those different things that the blind people have to be cognizant of. But this is just an additional sensor that they can start to get familiar with robotic sensors and understand what's going on. So it's going to be a learning curve for the blind visually impaired. And then the ultrasonic sensor, the program I'm in to get funding from the VA, they're just going to buy my supplies. And they're going to buy me a 3D printer and filament. I'm going to include a case for the LiDAR and then hook the ultrasonic sensor. So it'll be a package, and I'll hopefully put an iPhone on the back of that. So someone with a wheelchair, or you can have your neck lanyard version if you want. So that's my plan, 3D print a housing for these two sensors.
Brian, you said something to me a long time ago. I'll never forget about navigating visually impaired indoors, and a lot of it's about just finding the hallway, you know.
Yeah, it's quite a process, and we'll all probably admit to we are pretty mundane as far as our daily routines, and so the blind are the same. You know, I bike the same path that I've been biking for the last 16 years. So we do navigate, but if you really need these sensors, when I go into new dark restaurant that I don't know about, this is really when I rely on these. One of the first meetings I went to at Homebrew Robotics, I was sitting in the back with my white cane. I don't think anyone noticed me, but someone spoke up and said, you know, robots are blind. And I said, hey, I am too. But yeah, navigating indoors, if you've ever been, well, you've probably never been to a national convention with about 3,000 blind, visually impaired people all using canes, a hotel, if they're unfamiliar with, about 20, 30 guide dogs. And someone called us bumpers because that's how we navigate around. If you look at my eyebrows, I don't have any. It's scar tissue from bumping. There's actually a blind group called the bumpers. And my shins, I got more scar tissue on my shins and anyways, I don't want to go there. But so that's how we navigate bumping. And that's why additional sensory information is important to add to that white cane to provide and to bring the blindness community to the 21st century.
So I have a question. Have you considered just making a device that mounts on an arm or a leg or an ankle that senses level changes and openings and things like that instead of pain?
There are academia, I didn't touch on them, and several people keep sending me things for academia who are signed up for a course or about one sensor, and that's all they know about the sensor. And there's a couple sensor products out there that use a Fitbit with a sonar sensor, and then someone stuck an ultrasonic 5-foot range on a cane. The trouble with that is sensors won't, you know, you have to have a lot of sensors to detect drop-offs in the surface. So you really need the white cane at this point in time. And then if you go to the grocery store and you come back with 4 bags of groceries and a Starbucks in your hand, I mean, how are you going to hold on to these sensors?
Well, that's why I was thinking of something that mounted actually physically on the person around a wrist or an ankle so that they're not trying to carry a cane while this is going, or a dog user.
Yeah, well, that's why I have a neck lanyard version, which I have here. And so I am going to, once I print the 3D case for this, I'm going to make it so it'll fit. Because I spoke to a group, actually a national group of the blind who call themselves the bumpers. And this little old lady said, I'm in a wheelchair, what can you do for me? And I said, well, when I print my 3D housing, we'll put a wheelchair clamp or put this on a neck lanyard and you can hang it around your neck and you'll get that extra bit of sensory information. But you can't rely on this totally. With my guide robot, if I had the, you know, in the future, it'll be a totally autonomous type of a device that can actually pull you gently, nudge you along on a path that you plug into your GPS and take you along. That's the idea behind the guide robot. But we got to get the society desensitized about robots. And so the smart cane for the blind and blind rehab. I won't go into blind rehab, but yeah, I tried to get them to put a mini guide on the cane for extra sensory information, and they won't do. You know, maybe I got to go to a different blind center. But so there's a lot of hurdles, and so we have to take, like water, the path of least resistance. And so after 20 years in blind rehab, this is the path that I'm taking.
Hey, Brian, this is Osmond. I have a question. Do you think the sensor technology that we have available today is good enough and it's just a matter of processing the data or building better mechanics, or is there a different type of sensor that you would like to have that we don't have? The technology is not available yet.
Now, I think the technology's there. The autonomous vehicle, you know, it drives around on roads. So I think if we, and the NITO had 7 sensors. The sensors are there, and there was this European group that I showed, the MDI or the ISP, whatever it was. They actually did, the end of 2019, they had this international group that said, we can put all this on a cane, but it was too big. That they didn't let people know. But they said LiDAR, and then the Intel Sense flow sensor, sonar, and ultrasonic. So those 4 can build you an autonomous robot that can guide people around. Then if you can tie that to a smartphone with talking GPS, and then build that into wheel encoders. My patent shows a wheel that's why I use the wheel. Most white canes have a fiberglass ball on the end, or cube, or whatever. But mine has a wheel, and the patent that it's filed shows a wheel that can be hooked to and can slowly guide people along just with the cane. But I think that guide robot, you're gonna need that size to handle all the sensors and processing and battery and so forth. So I think it's possible. It's just a matter of finding, you know, the resources of the group or whatever to put this together.
Brian, may I ask another question? I played with NVIDIA Nano, Jetson Nano, and it does have stereo cameras, and basically its vision is very good. Outside, inside, it can detect objects, people, whatever you program it. So the vision problem for the robot is by now gone. The problem is now having all that visual information, including the stereoscopic 3D information, how you channel it into your brain per se to understand that scenery.
Yes. I'm sure there's a lot of sensors out there that are probably far more sophisticated than what I'm utilizing. And again, I'm just trying to break ground because no one else has done this yet or really is interested in doing it. But so audible signals, and that's what this has here. Tactile, I've seen a lot of things on the internet. People will take a glove and put all kinds of feelers on your hand. Some kid did a YouTube video of the latest iPad that's out that's got LiDAR in it. The latest iPad Pro 12.9 has LiDAR scanner sensor in it. And he had all kinds of tactile sensors that you can feel. But to get back to your question, audible is probably the best. And I can, you know, close my eyes or get blindfolded and go around a restaurant and not bump into anything, move this up and down, maybe to check everything, but I'll find a clear path with this audible clues from this. So any sensor that can generate audible clues, and that's what the mini guide does too. Now the mini guide also vibrates. That's the other thing with the mini guide. It provides audible signals and it provides vibrating signals. The closer you get to an object, the more it vibrates, and so does this LiDAR that I have. The closer you get to an object, the more it vibrates. And then, of course, well, it's audible piezo speaker for most of the sensing. And then when I get real close, that's when the lily pad vibrating sensor comes into play. So audible clues, I think, or tactile vibrating.
What comes to mind is wearables. You know, you can have wearable vibrators positioned all over your body, and you can connect it to differently positioned, you know, sensors, and it will vibrate on your left, on your right, on your back.
Shiloh built the LiDAR hat.
Yep. Again, that was 360, Shiloh. And I only concern myself with 10 degrees. But wearables, see, that's the issue. You know, if I go to Starbucks and get a cup of coffee, is my coffee in my hand going to get in way of the wearables? I mean, and to sell this to a market or a blind rehab, that's why I'm starting with the cane. Well, I started with a robot, but that was too scary. So I've moved to the cane, which every blind person uses, and we're just adding new sensory information to the cane. Wearable computers, lugging a grocery bag, you're going to block that vest. There's a lot of old photos of a nice vest with all kinds of sensors all over it. And it's great until you have to, grab that grocery bag and lug it home. Or lug your grandchild across the, so you need, I don't know, this is why I'm sticking with the cane. And I know, and plus the cane provides identification too. So there's a lot of blind rehab components that roll into the cane. It identifies that I'm blind, like my signs on my bike. A great story, before I put those signs on there, I was biking one day and I almost cut this other agitated biker off, and he yells at me, he said, "What's wrong with you? Are you blind?" And I said, "Yes, as a matter of fact, I am." So that's why the white cane is a good sign. There's wearables, and Silo's hat, or Dave and Silo's fantastic hat that we actually tested at a blind center, or a blind meeting space.
Brian, in your specific situation, you can see in the tunnel vision, you can see in the middle of your eyesight, right?
Yeah, I have pinholes, probably 2 degrees. An average person has 180, and I have like 2 degrees.
But there are enough pixels in that 2 degrees that you can see more or less clearly, right?
Yeah, well, actually, I'm starting to notice that there's a real phenomenon. My hearing is far superior because my visual cortex isn't being used anymore by 576 megapixels. Probably I'm only using, actually less than the guide phone here. That's 12 megapixels. Maybe I'm using less than that. But the visual cortex and hearing and other things will take it over. I'm starting to notice that I can see something, but my brain, like I got 4 different keychains to get around at work and get here. And I pull a keychain off and I look at it, and my brain is seeing those keys, but my brain isn't right. Is this the key I need for this lock? So my brain is starting to, even though I can see something, is not necessarily recognizing. So I've started to feel the key first, and I said, "Oh, that's the key I need for this lock." So tactually, my brain knows more than my eyes do.
Let me finish with my question, actually. There is a technology that employs glasses with basically television screens built in them. So, I mean, some kind of screen. Now, they're used for flying quadricopters, for example, races, quadricopters. or Google glasses. Microsoft had a similar product. Can your vision be corrected by wearing that type of glasses? Yeah, Google glasses, exactly. Do you see wider angle or it's still impaired?
Yeah, there's a variety company that's doing video, but video, again, I don't have enough fields to see what they display on the glass. This is from Israel. This is called the Orcam. This is an amazing device. I've seen 2 iterations, and it's magnetic. It's this tiny little camera that is an OCR device. And it will do face recognition. It can detect colors, detect money. It's an amazing, they've done a fantastic job with this technology, and they're an Israel-based company. So it's modeled after Google Glass, but there are a lot of companies trying things, but they don't have the experience that I have with 20 years in blind rehab and being blind. And I think that's where I probably have a real benefit, is that I understand what other blind people are going through. And I make these practical. My smart cane for the blind actually, like I said, has a wheel on it. It folds up, it goes in my backpack. You can see the phone on it. So this is my cane. So when I bike to work, I unfold this smart cane and it's ready to go. So this is where I am in my journey.
All right. All right. Thank you very much. As Brian says, we take our vision for granted. Robots and sensors can be quite help to those who are blind or visually impaired. For that matter, robotics can enhance the life of those with disabilities of all kinds. Brian, thank you for your work, your patience, and your determination.
Camp, can I ask Brian to do something first?
Shoot.
Brian, could you play that YouTube? This is Ed Katz. Could you play that YouTube? It's only 1 minute long, but since you mentioned it, I thought since I'm here, I might comment on it for the club.
Yeah, Dan, can you do it, or I can run it on my laptop maybe? I don't know which is easier.
So while they're setting it up, Brian came to me when I was at CMU, and we were talking about how we could build a robotic device that might prototype some of the things that Brian wanted to do. And I think it was a Robot Club meeting that we were at, and someone from NITO had walked right in front of us. And I thought, well, why can't we just leverage a NITO robot? So that sort of was in the back of my mind, and then I suddenly ran into, this is about a year ago, later, and I ran into some money to pay a student researcher, and I just found the right student researcher who ended up working for NITO, but that's another story. But anyway, we developed, which you'll see if this video will play, our test run of a robot leading a blind person through a building from one room down the hall to another room, doing wall following and finding doors and whatever. And yes, this is it. So it's only 1 minute long, so watch carefully. And yes, there is a stunt double in this. In case he looks familiar, don't worry about it. Okay, so somebody needs to start it. There we go.
The audio coming through?
So there we are, and it's starting now. It's localizing. It's moving to line itself up with the open door. Okay, it's lined itself up. It's moving towards the door, avoiding the door frame. It's now going to turn and go down the hall to the room. You notice that stripe along the dark border in the lower left-hand corner, that white stripe? The white stripe there is just masking tape, and that's because that dark border wouldn't reflect enough IR light from the LDS camp, laser distance sensor for the,
That's the problem with black, isn't it? It doesn't reflect light.
yeah, so the NITO couldn't see it, so we had to put the masking tape on there. And so we did that in about 6 months, working part-time. She was a full-time student, I was a full-time professor. And we met a couple of times a week. And so that's the project that Brian was mentioning. Oh, yes. So I also gave a technical talk on how we did that in December of 2017 to an IEEE Robotics Society meeting. Camp was there, along with some other people. And if the club is interested, I can give an encore presentation of the same talk.
Might need that for August.
Okay, well.
All right. So now we go into random access for a while. The next meeting will be the SIG on August the 19th and the real meeting again on August the 26th. I'd like to thank everybody for showing up and participating, and especially you, Brian. Keep up the great work. Thank you very much.
Thank you.